Hello everyone, welcome to the X2O Mechanics Academy. It's Fernando here again. Today we're going to talk about the fuel tank leakage diagnosis. First, we're going to start from the fuel tank pipeline system first. Let me introduce the different parts of the fuel tank pipeline system. For example, this part directs to the motor, and this is the digital motor electronics. Sometimes the trouble codes may be caused by the malfunction of the DME part. And this part is the NVLD sensor. And this part is the NVLD pump. NVLD is natural vacuum leak detection. And this part is the activated carbon filter, which can storage the evaporation of the fuel. And this is the fuel tank. It can transmit fuel directly to the motor. And those red lines means the pipeline for evaporation. Before we perform the fuel tank leakage diagnosis, there are several conditions to be met. The first is to make sure that the engine is cold. We need a cold engine start. If it's not cold, it should be cooled down over 8 degrees Celsius and last for at least 1 hour. The second condition is that the altitude should be lower than 2,500 meters. Another condition is the battery voltage should be between 11 to 16 volts. And the environment temperature should be higher than 4.5 degrees Celsius. Another condition is the fuel tank vent valve should be closed. It's very important before we perform the fuel tank leakage diagnosis. Then the bus terminal state should be either the running state or sleep mode. In other words, the vehicle should be just running or powered off over 10 minutes. Another condition is to make sure that the pressure difference between the engine is on and off should be less than 6 hectopascals. A bigger pressure difference may affect the ability to detect small leaks. And the last condition is that we do not distinguish the differences between small leakage and micro leakage. We only care about if the leakage is greater than 0.5 millimeters or not. Now let's come to the second part, the mechanical states of the NVLD pump. Due to the structural design of the pump, there are 5 distinct states. The first one is the static state, which means it's not working. The second one is the switch closed status. That means it's off. The third state is the purge air state. That means it's actively running and let the air flow through the pipelines. The fourth state is overpressure state, which means the pressure inside the NVLD is higher than normal state. This may trigger a trouble code. And the last state is the refueling state. This only happens when the fuel tank is refueling. In the end, I must mention that the fuel tank vent valve is closed when there is no power supply. It's very important because it can prevent the fuel vapors from the activated carbon filter from entering the motor's intake manifold. At last, I will summarize the possible leakage points in the pipeline system. The first is the fuel tank filler cap, then the vapor pipe joints, the tank joints, and the joints of the activated carbon filter, the NVLD pump, the fuel tank vent valve, the fuel tank pump joint, and the last one is the motor intake manifold joint. If none of the joints can be detected of any leakage, it means maybe malfunction of the digital motor electronics. That means we need to upgrade the software. So much for today's content, and thank you for watching. Don't forget to like and subscribe. See you next time.